measures of center and measures of spread. So first, let's look at measure of center. Before we look at specific ideas, first let's talk about a quick notation. This notation is called sum notation. Many of the formulas use this sum notation. This means that I'm adding all the data values, x1, x2, all the way to xn. And n refers to how many number of data we have. So first, let's look at the idea of mean. For mean, we have two types. One is called sample mean and one is called the population mean. So it depends on where we get the mean from. Is it either from sample or population? The way we use symbols or notation is different. The way we calculate, the calculation is essentially same, but we need to distinguish. And this becomes more important later on. So it's important to distinguish is as the sample mean or population mean. Specifically, we call it this a type of a statistic. So sample mean is a type of a statistic, and population mean is a type of parameter. So sample mean, we're using this symbol x bar. We pronunciate x bar. X bar, that's how we say it, x bar. And the way we calculate is with all the data given a set or given a sample and divide by how many we added. For population mean, we call this symbol right here mu. This symbol is called mu. And calculation is we add all the data values in the population and add how many we added. Okay. And oftentimes you see a capital N instead of lowercase n as well. Okay. And we're probably familiar with this idea of mean, though we often refer to it as the average. Okay. So let's look at an example of how to calculate a mean. A city issued following number of building permits over a 6-month period: 3, 10, 296, 240, 374, 190, and 280. Find the mean number of building permits given out over a 6-month period. So here, total number of data is 6. So what we do is we add all of them and we divide by how many we added. So although here it doesn't specifically specify sample or population, oftentimes it's implied as sample because a lot of real life data we collect are sample, not entire population, unless we define it to be population. But for mean, the calculation doesn't change the way we calculate. So let's just add all of them, divide by how many we added. So let me write it here. Mean equals, and I'm going to add all the numbers in the numerator like this and divide by how many we added, 6. And make sure to try this with your calculator. So if you add all these, you get 1698 divided by 6, which equals to 283. So this is the mean number of permits given each month. Okay, so let's look at another idea for measuring center: median. Another measure of central tendency or measure of center is called median. Median is useful because it's not so sensitive to extreme values. Here, the extreme values I'm referring to especially outliers. Outliers. Instead, it divides group into observation into 2 parts with a half of numbers below the median and half above it. Perhaps the most used case for median is when we talk about median income. It's because if we have an outlier, if we have a family who makes a lot more money compared to their neighborhood, for example, then they'll be outlier. So then that outlier would affect the average, the mean income a lot. But median is not so much. That's why it's very useful to use median in those cases. So this is how we find median. First, when we get a data, we need to rank them, essentially write in order, arrange them in a numerical order from least to greatest. And then if the number of items we have are odd, then median is the middle number. If we have an even number of items, even number of data, then median is the mean of the two middle items. So let's look at an example. So in this example, we have 1, 2, 3, 4, 5, 6, 7. In the letter order, we have 7 number of item or data. So the median is this number. This is the median. Now in second example, let's see how many data we have. 1, 2, 3, 4, 5, 6. We have 6 of them. And also, this is not in order. So first, we need to order them. So let me write in order. 132, 147, 159, 174, 181, and 253. And make sure you count it back. We have 6 number of numbers, 6 number of items. That's why I count it first, because when you rearrange it, we don't want to miss a number, because that could change the median. So then we have 6 numbers, and since it's even number of items, we add these two and divide by 2. Like this. We add the 2 middle number and divide by 2, and this number is the median. For median, we can also find the position of the median. So is it the first item, second item? Once we put in order, easy way to find the position of the median, position, not the median value itself, for n item is we do n plus 1 divided by 2. So this formula only gives the position, not the actual value. So for example, we have 6 items here. If I do 6 plus 1, I get 7 divided by 2 is 3.5. So between 3 and 4, the median lies here. For the earlier example, there's 7 items. So if I do 7 plus 1, that's 8 divided by 2 is 4th. So 4th item is the median. Mode. The third important measure of central tendency, or measure of center, is the mode. The mode is the data set value that occurs the most often. So for example, 10 students earned the following scores in the history exam. Determine the most score. So we make an observation here, and we see that 74, 74, 74 appears the most. So mode is 74. The mode is measure of center for qualitative variable, categorical variable, whereas mean and median are for quantitative variables. Okay, so something to keep in mind. And it's possible to not have mode. Look at this data. There's no data that occurs more than once. There's no mode in this example. So that's the difference also between mode and mean and median. We always have mean and median in quantitative variable or quantitative data. But mode, sometimes we might not have it if it all appears once. So before we look into more the central measurement or measure of center, let's look at some distribution shape. In quantitative variables, as we saw in earlier sections, in regards to histogram, in quantitative, once we draw a histogram, we can recognize some shapes. So this right here has this kind of shape. So it's not perfect, but it has this tendency, and this is called skewed right. Skewed right. And this one, let's look at this one first, and I'll come to the middle one. This one is kind of opposite of the one we just did, it's called skewed left. And we'll talk about meaning of this in a second, but for now we're just trying to recognize these shapes. And we also have symmetrical shape. We also call this symmetric shape sometimes bell shape. because it looks like a bell, like a bell like this. Okay. So it is important for us to recognize this, and let's talk about why we need to distinguish this shape in relation to mean and median. So here's the skewed left. In skewed left, so when we have a data set, quantitative data set skewed left, the median is larger than mean. In symmetric, if it's perfect symmetric, mean is equal to the median. And if we don't have a perfect symmetric, then mean and median are very close. If it's skewed right, the mean is actually less than the median. So depending on what types of data we have, and of course not all data we collect, quantitative data we collect, will fall into 3 of these shapes. But if you can recognize between one of these shapes, we can compare mean and median values. So range is for any data set. Range is a set of defined as greatest value minus the least value in the set. Okay, so we're just find the difference between greatest and smallest. That's how the data ranges. So let's look at the last example of a center measure. Then we'll continue with measure spread. So interpret the scores that Max and Molly made on 5 quizzes and discuss your finding in relation to mean, median, and range. So we're going to calculate these values, and we're also going to make some interpretation. What does it mean, especially in comparison to each other? But before I begin, I actually suggest you pause the video and try on your own first. Pause the video and find the mean, median, range on your own first. And then come back, then I'll go over it. So let me find the mean for Max. So mean for Max is add all of those numbers. Let me just write it first. There are 5 scores, this is 5 quizzes, so I get median as 23. And let me find the median for Max. Excuse me, we need to write the numbers in order. So for median, let me write in order first. So median is 22. So let's write 22 here. And the range is smallest number minus the least number, which is 10. And let's go over Molly's score. The mean is also 23. Median, let me write in range. Let me write in order. Median is 27. And the range, if I subtract these 2 numbers, I get 2. Oops, sorry, 12. 22. 22. 22. Okay. So now let's compare Max and Molly's. Both have same mean score. So mean score or mean value is very important in general, but we don't only want to rely on mean, because all the means are scored, their median is different and range is different, right? They have the same mean, but Molly has a greater median. So what does that mean? This means Molly's score are greater than 27, because that median is right in the middle. So half of Molly's score is greater in the middle. So we can make several interpretation to this. Molly had more consistent quiz score, except for quiz 4, because she had a very lower quiz score in quiz 4. So the score of 6, which is quiz 4 score for Molly, is a extreme outlier. Okay. Whereas Max, the median was lower. Right. So for Max, we can also tell that there's no outstanding outlier either. Okay. So we can make many interpretations to do this, but this is just a simple way of summarizing it. So now we're going to talk about the measure of spread. And the measure of spread is important, particularly because we often don't want to just look at the mean value. We want to see how data is spread. So in this example, Molly's data is more spread because of this outlier of 6, right? So we're going to look at how we measure spread in a data set. Measure of spread. So in order to measure spread, we use this idea called standard deviation. Standard deviation is based on the deviation from the mean of all the data values. So we're going to see, given the data, we're going to see how much each data is deviate from the mean value. So let a sample of n numbers of standard deviation, then standard deviation S number of calculated as follows. So usually when we say S, we refer to sample standard deviation. So just like the mean, this is standard deviation that comes from the sample. And this is the formula, and we'll talk about the formula. And we also have a population standard deviation. The standard deviation comes from a population. Then we use different notation. This is called sigma. Sigma. And actually, the formula is also a little different. For population, we divide by how many we added, number of data. For sample standard deviation, we divide by n minus 1. So we divide 1 less than the number of data. Okay, so this is a very important distinction. So for standard deviation, it's very important to distinguish, is it coming from sample or population? Is it sample standard deviation or is it population standard deviation? It's very important to distinguish that. Okay, so here's some steps how to calculate. Let me go over this and let me demonstrate with an example. First, we need to calculate the mean. So if it's sample, it would be sample mean. We can also do population mean. And find the deviation from the mean. That means from all the data, I'm going to subtract data value minus the mean to see the distance between each data value and the mean. And we're going to score each deviation. And we add all of the deviations and divide by either n minus 1 for sample standard deviation. And we divide by capital N for population standard deviation. And take the square root of the number we get from 5 for the standard deviation. So let me do an example here. So in this example, it says find the standard deviation of the following sample. So since this is from the sample, we're doing sample standard deviation. And oftentimes, we can only find sample standard deviation, especially in our class, is because, as we talked about earlier, it's difficult to get entire population. And of course, we can just define this to be population as well. But at least in this section, we'll see sample standard deviation. But later, we'll also look at population standard deviation. And oftentimes, population standard deviation will be given in a problem. Okay, but for now, let's focus on how to find sample standard deviation. Again, this is important to distinguish because formula, which you do not need to memorize, will be provided for you. Sample standard deviation, population standard deviation have different formulas. So it's important to distinguish between these two. Okay? So how do we approach this? So first, we need to find the mean. Since it's sample mean, I'm going to add all these and divide by how many I added. So I get 23. Make sure to have a calculator and try on your own. Once we find the mean, what we're going to do is I'm going to create a quick table. So let me draw it first, like this. And here, first, we write data value. These are also known as x or xi's. So these are also known as x. And for second, right here, we're going to write deviation from the mean. And third, we're going to write score of deviation from the mean. So this means deviation. And we'll square this value on the last row. So let's list all the numbers. So we have 7. So create a table. I list all the data values from here. Make sure you have all of them. Let me zoom in a little more. Okay. So then what we do is, here we want to know how much 7 is deviated away from the mean. Since mean was 23, so I do 7 minus 23, which gives me negative 16. And for 9, how much 9 is away from the 23? 9 minus 23 equals negative 14. And it's okay to get a negative number. 18 minus 23. So we do all this. We find deviation from the mean from each number, each value. So let me fill that in. Okay, so these are all the deviation values. So now for the last column or last row, what we do is we square each of these. I square each of these numbers. So let me square this number. I get, just using a calculator, I get 256. And you should get only positive numbers here because we're squaring a negative number, gets positive. Squaring a positive number gives us positive. Square this. Oops. 196, 25, 1, 16, 36, 81. And this one, using a calculator, I get 289. Okay, so we did all the steps up to 4 right now. Oh, sorry, up to 3. Then we're going to add all of these. So then we add all these numbers. So if I add all these, sum, I get 900. So we get 900. And we need to divide by n minus 1. Here, n is 8. We have 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. So we have to do 900 divided by a minus 1, which is 900 divided by 7, which is 128.571. So we can keep 3 decimals. Usually when we estimate, when we're around to decimal, we want to keep as many as decimal during the intermediate steps. Okay, so 3 should be good enough for here. And then for the final standard deviation, for S, is square root of this number. Square root of this number. 128.571 is about 11.3389, but I'm going to round to 3 decimal. But let me see, 339. So this is the standard deviation for this problem. So that means this data set is spread around by 11.339. Obviously, if the bigger the number, that means data is more spread. The smaller the standard deviation means the data are clustered around the mean. And that's how we interpret the standard deviation. Okay. So again, let's kind of summarize what this calculation means. What we're doing here is we're essentially seeing how each of these data values are far away from the mean by subtracting the mean value. So these are the distance. Negative means they're left side of the mean. Positive means they're right side of the mean, greater than mean. Right? So we get all the distance and we square them. Okay? And we add all of them and divide by n minus 1. So we do n minus 1 because it's a sample standard deviation. Sample standard deviation. Standard deviation. Okay, let's write it short. So why do we do n minus 1, not n? It's because it's from sample. We're not 100% sure if this standard deviation represents the population perfectly. And oftentimes it doesn't. Sample cannot always represent population perfectly, right? So by dividing by n minus 1, which is dividing by smaller number, we're actually getting a bigger number here, right? If I divide by 8, I'll get a smaller number here, right? So we're getting a little bigger number. And take the square root, also get a little bigger than if I were to divide by 8. So Just to be sure, we want to have a little bigger standard deviation than smaller for sample. That's why we divide n minus 1 for sample standard deviation. For population standard deviation, we just divide by n, how many we added. So make sure to practice this on your own. Know how to calculate standard deviation, especially sample standard deviation, by dividing by n minus 1. And always pay attention for that word. Sample standard deviation, population standard deviation depends on. So it depends on, is it parameter or statistic, as we talked about earlier. So sample standard deviation is a statistic. Population standard deviation is a parameter.